Inverse variation. Our objective is to identify, write, and graph inverse variations. Why learn this? Inverse variation can be used to find the frequency at which a guitar string vibrates. Let's look at what inverse variations are. So in words, y varies inversely as x. So y equals 3 over x, or in algebraic terms, k over x. K is our constant. You can also state that y is inversely proportional to x, meaning x times y is going to equal your constant. There are two methods to determine whether a relationship between data is an inverse variation. You can write a function in the rule y equals your constant divided by x, or you can check to see if x times y is constant for every ordered pair, meaning when you multiply x times y, the same number you get for all of them. So we're going to tell whether each relationship is an inverse variation, and then we're going to briefly explain. So method 1, write a function rule. Well, y equals, and what's the constant rate of change that keeps happening? Well, 20. So 20 over x. So because you can write it in this form, it's an inverse variation. But let's look at method 2. So if we have 1 times 20, and we multiply each of these, we end up with 20, 20, and 20. So, therefore, x, y ends up equaling 20. So the product is constant, so the relationship is an inverse variation. Let's take a moment and try B. So we want to write a rule. So we keep increasing by a multiple of 3 here. So therefore, y equals 3x. Well, that's not an inverse variation. So therefore, B isn't an inverse variation. But let's check our x, y. So if we multiply, 2 times 6 is 12, 3 times 9 is 27, and 6 times 18 is 108. There's not a constant change, so therefore it's not an inverse variation. Doesn't matter which method you use, you will still end up with the same result in the end. So now take a moment and pause the video and try these next 4 on your own. When you return to the video, the answer for each will be revealed. And there you have it. An inverse variation can also be identified by its graph. Some inverse variation graphs are shown. Notice that each graph has 2 parts that are not connected. Also notice that none of the graphs contain 0, 0. This is because you can never have 0, 0 as a solution of an inverse variation equation. It kind of puts the 0 in the denominator, which doesn't work out so well. So, they're always kitty-corner to each other, meaning if you're in this quadrant, you're going to be in the quadrant opposite that, diagonally, if you will. So, you have y equals 1 over x, and it's going to go through the point 1, 1. If you have y equals negative 2 over x, it's going to go the other direction since it's negative. Now let's take a look at graphing them. So we want to write and graph the inverse variation in which y equals 2 when x equals 4. So we need to find our constant value, the one that is their constant of variation. So we're going to take our x and our y, and we're going to multiply them. So we have 4 times 2, and we end up with 8. So now we're going to use the value of k to write an inverse variation equation. So you found your k value, so now you're going to substitute that back in. Remember, to be able to make a table of values, you need to have the variables x and y. You don't want numbers in for them right now. So we want to solve to get a numerical value for our other variable, the k, so that way we can make a table of values. And in this place, we got y equals 8 over x. So now let's use the equation to make a table of values. So we're simply going to plug in our x value, and then we're going to do 8 divided by negative 4, which gives us negative 2. Then we have 8 divided by negative 2, which gives us negative 4. 8 divided by negative 1, which is negative 8. Remember, we can't have a 0 because it makes it undefined. 8 divided by 1 is 8. 8 divided by 2 is 4, and 8 divided by 4 is 2. So once again, we just substitute our values of x in and get our output y. Now we simply plot the points and then connect them. Keep in mind you're going to have 2 pieces, so it makes it inverse. So now let's try writing and graphing the inverse variation in which y equals a half when x equals 10. Take a moment and pause the video and try it out on your own. When you return, the answer will be revealed. And there you have it. So step 1, find your k value. Step 2, write your inverse variation function. Step 3, make a table of values. Step 4, plot your points. So now let's try a music application. The inverse variation, xy equals 2,400, relates the vibration frequency y in hertz to the length x in centimeters of a guitar string. Determine a reasonable domain and range, and then graph this inverse variation. Use the graph to estimate the frequency of vibrations when the string length is 100 centimeters. So step 1, we want to solve for y, that way we can actually graph it, since we already have that x times y is 2,400. So divide both sides by x. Now, we're dealing with a real-world application. You can't have a negative length for a string, and when they're both going to be positive, so is the y value. So our x and y value both are going to be greater than 0. So we only need quadrant 1. Now we're going to pick some values and we're going to plot the points. So plug in 20, and when we plug in 20 we end up with 120. When we plug in 40 we end up with 60. When we substitute in 60 we end up with 40. And when we substitute 120 in we end up with 20. So now we just want to plot the points. So when we plot the points, we're going to have our graph. Now we can estimate the value or the frequency of vibration when the string length is 100 centimeters. So go to 100 centimeters and then go up, and it's about 24 hertz. We can use the fact that x times y equals k is the same for every ordered pair in any inverse variation. This will help you find missing values in the relationship. So think of it this way. For one coordinate, if you multiply your x and y together, it should be the same as if you take another coordinate and multiply your x and y together. Let's check it out. So we're going to let x sub 1 equal 3 and y sub 1 equal 2. and y sub 2 equal 6. Y is going to vary inversely as x. So that tells you you're dealing with an inverse variation. So that way we want to find our x sub 2. We're going to use our knowledge of the inverse product rule to help us out. So we have x1 times y1 is going to equal x2 times y2. Now let's just substitute our values in. So 3 times 2 is 6. So we have 6 equals 6x sub 2. So divide both sides by 6, and we end up with 1. So our x sub 2 is 1. The x value in our coordinate 2, if you want to think of it that way, would be 1. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. So now let's look at a physics application. Boyle's law states that the pressure of a quantity of gas x varies inversely as the volume of the gas y. The volume of air inside a bicycle pump is 5.2 inches cubed, and the pressure is 15.5 psi's. Assuming no air escapes, what is the pressure of the air inside the pump after the handle is pushed in and the air is compressed to a volume of 2.6? So we have a volume of 5.2 inches cubed, and the pressure is 15.5 psi's. But now when we push the handle in, we have a volume of 2.6 inches cubed. So what would be the pressure that's found? So we're going to substitute our values in that we know, and then we're going to simplify. So therefore, if the volume is 2.6 inches cubed, your pressure is going to be 31 psi's. And that ends our video lesson on inverse variation.